Hello. In this video, let us look at the solving the same system of equations that we did last time. Only this time we're going to use elimination instead of substitution. So here is the system, and let us say that we were told to solve using elimination. Now, here is the question, and it's the same system. 3x plus 5y is 15, and the second was x plus y is 2. So the elimination is also known as addition, because the idea is to add the two equations, but to add them in such a way that one of the variables cancels off. Either the x drops off or the y drops off. And the way it is right now, if we add both equations, nothing will cancel. So if we have this equation, 3x plus x makes 4x, 5y plus 1y makes 6y, and 15 and 2 is 17. So even though we added the two equations, nothing happened. Nothing that we could use, because we now have one equation and two unknowns, 1, 2. And we need as many equations as we have variables to get a unique solution. So if I have one variable, then one equation would allow me to get that one variable. But if I have two variables, like I do here, 1, 2, then I need two equations to get that solution, not one. So unless one of the variables cancels off, this method will not work. So what can we do? Let's start off again. Here is the same system. 3x plus 5y is 15. X plus y is 2. So when we add, we have to make sure that one of the variables cancels off. And to do this, we need to have the same number in front of that variable with opposite signs. So if I wish to cancel the 3x, for example, I need to have the same number in front of x with opposite signs, like 3 minus 3, 6 minus 6, something like that. To cancel the y's, I need to have the same number in front of y's with opposite signs. Now we can multiply both sides of our equation by any number other than 0. So to see which letter is easiest to cancel, we could look at the idea of the least common denominator. So for the least common denominator, let's see for the x. For the x, the numbers in the front are 3 and 1. So if we were looking for the common denominator between 1 and 3, what is the smallest number that can be divided by 1 and 3? And that answer would have to be 3. 3 is the smallest such number that can be divided by both 1 and 3. So to cancel the x, all I need is plus minus 3. I already have plus 3 in the first equation, all I need is minus 3 on the second, and since I can multiply both sides by any number I wish, other than 0, I will multiply both sides of the second equation by negative 3. Negative 3. So here comes the first equation. We copy it over because nothing happened here. And the second equation, each number gets times by negative 3. So negative 3 times 1 is negative 3x. Negative 3 times 1 is negative 3y. And negative 3 times 2 is negative 6. Now, this time when we use addition, we should actually see the elimination happening. The x's cancel off, because if we add 3x minus 3x cancels, and 5y minus 3y makes 2y, and then 15 minus 6 makes 9. So at this point I have canceled the x and I have just one equation, one unknown, and I can find what that unknown is. To do that, all I need is to divide both sides by 2 to cancel multiplying, and I got y equals 9/2. That's the same y coordinate as we had from the solving using the substitution. Now all I need is an x. At this point, since I have the y, I can go back to my equations and use substitution and substitute the y 9/2 either here or here. Let's use the second equation. It's easier because it has smaller numbers, and we'll substitute it in that equation. So here is the second equation. It was x plus y is 2, and we now know that y is 9/2, which makes x plus 9/2 is 2. To get x by itself, all we need is minus 9/2 from both ends of our equation, and we are done. At this point, we can use calculator, or we can do it by hand. By hand, we need common denominator of 2. 4 minus 9 is -5 divided by 2, which is -5/2. So x is -5/2. That's the same coordinate, again, that we found using the substitution. So using elimination, here we have found the answer to be -5/2 and 9/2. That's the same result as we had with substitution. Now, for somebody who does not wish to work with fractions like we did here, we could continue and do elimination one more time, and this time cancel the y and get the x. So just for practice, let's do that. It is not necessary at this point because the question is already solved, but just to practice elimination, let's do that one more time. So here is the original question, and it is 3x plus 5y is 15, and then x plus y is 2. So this time, to cancel the y, the LCD for the y is a number that can be divided by both 5 and 1, and such number is 5. 5 is the smallest such number. So we need 5's in front of both y's. We already have it in the first equation. We do not have it in the second. And what we need is we need opposite signs. So we need to multiply both sides of our second equation by -5 all the way through. That makes -5x, -5y, -10. So if we were to rewrite our new system, we would get 3x plus 5y is 15, and then -5x minus 5y is -10. This time, when we add using addition, the 3x minus 5x is -2x, y's cancel off, they get eliminated. 15 minus 10 is 5, and so to get the x by itself, we divide both sides by -2, and we get x is -5/2, the same as we did with when we used the substitution into our second equation. So both ways we get the same, x is -5/2. It may be easier sometimes to use the substitution at the second part here. We just substituted the y as opposed to going back through the equation and doing elimination, but the choice is up to the user. So whoever is solving the question gets to decide. When we when we solve these questions, oftentimes in our homework, if it is online homework, the computer would ask to use a particular method. So you might get the question that says use elimination or use substitution or use something else. The computer does not know where the answers come from. It can only check if you found the right intersect or not. So as long as the final place where the two lines crossed is the same, the computer will not know how you came with the solution. So since we have two methods, elimination and substitution, both give the same result. Choosing the method that works for you best will work because there is no way to tell how you got the solutions. And so oftentimes the elimination will prove to be a little bit faster and a little bit easier to use, but substitution sometimes may be a little bit easier to follow. So choose what works for you. And that's all for this one. Thanks a lot for your time. In the next video, let's look at what happens if we try to solve an equation that has two parallel lines, so there would be no solution. Let's see what that looks like. Thanks a lot for your time. Take care.